Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. Pulse Width Modulation, or PWM, is used to control the average power delivered to a load by varying the width of the pulses in a periodic waveform. In PWM, a fixed frequency signal, which is also called the carrier wave, is turned on and turned off at varying intervals, creating pulses with different widths. The duty cycle, which represents the ratio of the pulse's duration to the total period, determines the average power delivered to the load. 50% duty cycle in pulse width modulation means that the signal is on for half of the total period. This implies an equal amount of time in the on state and the off state. 75% duty cycle means that the signal is on for 3/4 of the total period. So this implies that 75% of the time it is in the on state, and then 25% of the time it is in the off state. And if it was 100% duty cycle, this would mean that the signal is on continuously throughout the entire period. There is no off state. This is used in an example of dimming LED lights. So a PWM turns the power on and off very quickly, and the perceived output is changed by varying the duty cycle. It's how the signal is turned on versus turned off. So let's say you have a 10-volt LED light. When it's reading 0 volts, it's at 0% duty cycle. When it's at 25% duty cycle, it would be 2.5 volts. 50% duty cycle would be 5 volts. 75% would be 7.5, and when it's 100% duty cycle, it'll be at 10 volts. When it's at 2.5 volts, it will be dim, and as the voltage increases or duty cycle increases, the light will become brighter, and at its brightest, it will be 100% duty cycle, or 10 volts in this example. For pulse width modulation, frequency refers to the rate at which the PWM signal repeats its cycle, which is measured in hertz. So hertz is cycles per second. It represents how quickly the signal oscillates between the on and off states. The PWM frequency is a crucial parameter in PWM applications, and its selection depends on the specific requirements of the system. In something like motor control, including DC motors or 3-phase AC motors, a common PWM frequency range is usually from a few hundred hertz to several kilohertz. And for motors, higher PWM frequencies generally offer smoother control and quieter operation, but may result in higher switching losses. Whereas for LED dimming, PWM frequencies are often in the kilohertz range, typically above 1 kilohertz. Pulse width modulation can be utilized using a Maple modular PLC and a PWM module. An LED light or motor, for example, would be wired to a terminal block, which is connected to the PWM module and the PLC. Your PWM application would also be configured using a PLC control software, MapleLogic. So here in MapleLogic, I'm going to show the special configuration for setting up your PWM application. To open up this window here, you're going to go to Program, right-click on Program, New Program. Here, under Special Configurations, select PWM for PLC ES, and then hit OK, and it opens up this window. I'm going to go over briefly on the setup here in this window. Up here, slot, you would just choose which slot your PWM module is in, based on the amount of modules on your chassis. There are 12 PWM channels for the PWM module, so whichever one you're using, you would just select either channels 1 through 4, 5 through 8, or 9 through 12. So you would configure based on how many you're using. And then here, your frequency value and your frequency change time. This is also configured based on the group you're using, either it's channels 1 through 4, 5 through 8, or 9 through 12. And your max frequency for the module is 4,000 hertz. And your frequency change time is also based on the channel group you are using. And then here, for selecting the channel, you would just select the one that you are using. So for the high-speed output option, you would just check off the channel and then set up that channel individually if you're using multiple. And finally, configuring your duty cycle. So your duty cycle ratio and your duty ratio change time. This has a max range of 1000, and this of course is according to how long the signal or pulse is in the on state. Once you have your settings here, you would just click right to initiate your PWM settings. So this PWM configuration window can effectively change the duty cycle and frequency, for example, an LED light or a motor. It can change the brightness of the LED light from dim to its brightest. So at a low duty cycle, it would be dim, and then at a higher duty cycle, it would be bright. Or it can also affect the flickering of an LED light, or just pulsing on and off, depending on what kind of LED light you have. It can affect the speed of a motor. So at a lower duty cycle, it'll be at a low speed, and at a higher duty cycle, it'll be at a higher speed. And for both of those, you can change the duty ratio change time. So the amount of time it takes an LED light to go from its dimmest to its brightest, you would set the change time. So let's say it's set to 1000. That would actually be 10 seconds it would take to go from, let's say, 0 to 100 duty cycle. So it would go from almost off to its brightest. And then maybe for a motor, you want to affect the speed of the motor. So let's say set the change time to 1000 again, so 10 seconds, your duty cycle to 100, and so it would start at a low speed and then slowly speed up within 10 seconds all the way to 100 duty cycle. And that is essentially what this PWM configuration window is used for. And then you can also use the frequency change time. That's the same thing as the duty ratio change time. It would just change the frequency over a certain amount of time. So maybe you want to change the frequency from 0 to 1000 within 10 seconds as well. You would fill this out as 1000, which is 10 seconds. Now, not only can you use the GUI to configure your PWM, you can also configure your PWM control without using this configuration GUI by using the buffer memory in MapleLogic. So you would typically use the PWM configuration GUI if the settings are going to be always constant, but to utilize the PWM configurations in a use of automation to, let's say, setting up a condition to speed up a motor to a certain duty cycle and then slow down to another duty cycle, or changing the frequency of an LED light, this would all be done using the PWM buffer memory in ladder diagram logic. So the buffer memory can be found in the MapleLogic help files under PWM module and then buffer memory. So you just go to help and then click help, and then it opens up this window here, and then you would navigate to your CPU PLC ES, and then go down to PLC ES PWM module, and then buffer memory, and opens up this window here, and this is the buffer memory for your PWM module. Now you can turn on a bit to enable the PWM, which here is 0, and then also duty cycle channels and the frequency channels here, as well as the duty cycle ramp time and the frequency ramp time. So it can all be controlled within your buffer memory. So in the next video, I'll be going over the logic for controlling the speed of a motor by using the PWM buffer memory and utilizing application instructions and move functions to increase and decrease the speed of the motor over a period of time. And I'll be showing a live camera feed of the motor speeding up and slowing down. So this is all I'll be covering today. To get more information, please visit the MapleLogic tutorial page, What is Pulse Width Modulation, on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.